done finding zeros of polynomials. You would find your first one, or I gave you the first one, you do your synthetic, you could find zeros, you could do your factored form. This one, I have given you the factored form, and I want you to tell me all the zeros from that factored form. So, when it's all factored, when I ask for the zeros, I'm asking what numbers make this equal 0. So all you really have to do is set each piece to 0. So I need to know what makes 3x equal 0. So that's just 0. I need to know what makes 4x minus 5 equals 0. I'm going to ignore this exponent on the outside first. So if I add my 5, divide by 4, I get 5 fourths. Now, what does this cube mean? It's down there 3 times. So that is the multiplicity of the answer. That means 5 fourths is going to show up as an answer 3 different times. So to denote that, we're just going to put an M3 beside it. 5 fourths is an answer 3 times. Okay. X squared plus 3. If I set that equal to 0, subtract my 3. How do you get rid of a square? And with it we do plus and minus. Square root of negative 3. Now, that had a 5 on the outside. So what does that mean? Plus or minus I radical 3, multiplicity 5.
So we also do negative I radical 3?
I put the plus and minus, but if you did them separately, yes, you put I radical 3, multiplicity 5, and negative I radical 3, multiplicity 5. Question 6. Okay, so today we're going to bring back in a few pieces from before. When I look at a polynomial, how do I know how many zeros it's going to have? The highest exponent, the degree. So if it has degree n, that's at most n zeros. So it touches the x-axis at most n times. It doesn't have to do that many because you could have imaginary zeros. That's the most. We've also talked about multiplicity before. If you have that 4.1 handout, that messy stuff, I actually saw it. The very last thing we did at the bottom had a box and talked about the shape of the graph with the multiplicity. And it said if the multiplicity is odd, what happens? Read it, Taylor.
M is greater than 1.
Okay, and if that's true,
It goes to 1.
okay, so anytime you have an odd multiplicity on the graph, it goes through. If it has an even multiplicity, what happens? We use this a little bit just with matching. I can give you some pictures of graphs when we were trying to write their equations. So we've talked about it a little bit there. So we are going to start graphing polynomials today. And I'm going to give you a list of things that I want you to do when we graph our polynomials. And on test or quiz, I would prompt you for these. I'm not just going to expect you to do them all. I will have it listed out. A, I want you to do this. B, I want you to do this. Most of them are going to be pretty quick steps. It's just asking you to write something down so I know that you're thinking about the correct things as we go through the graph. So to graph a polynomial, first thing I'm going to ask you, what's the degree? The highest exponent. Second thing, we can find our end behavior. Remember we talked about that last week? We said if it's odd degree, its end behavior looks like x cubed, down, up. Even degree looks like x squared, it's up, up. If you have a negative in front, it flips those things. C, we are going to list all the zeros and multiplicities like we did on that example a second ago. Next, we will decide if the graph goes through or bounces at each zero. Next, I'll ask for a y-intercept. Remember to find a y-intercept, that's just when x equals 0. And once we have all these pieces, we will draw a graph. Now, I encourage you, use your graphing calculator to double check yourself along the way with these. You know, you can graph something and look at the end behavior. You can graph something at the end to see if the graph on your calculator matches the graph you did by hand. But I am going to expect you to be able to answer all of these questions about our polynomials along the way. So let's actually just look at a problem and put this into practice. First thing I want is degree. If you multiply it out, you have 2x times an x times an x, so you would get a 2x cubed. So you guys all agree your degree is 3? Second step, we are going to give our end behavior, which is just based off the degree. Degree 3, it's a positive coefficient, so what's your end behavior? Down, up.
I forgot how to even what the arrows were.
Okay. So we had really two cases. If it was odd degree, so if you think about like x cubed, x to the 5th, those are your chairs. They look like this, so your end behavior, the left side's going down and the right side's going up. If you put a negative in front of those things, that flips it, so it's starting up and ending down. If it is even degree, so if you think about like x squared, x to the 4th, those are the parabolas, so both ends are going up. If they were negative, that would flip your parabola upside down, so your behavior is down, down. And if you're ever not sure, you can graph it on your calculator and just tell me what the two ends are doing, the left and then the right. Okay, next question, zeros. And if it has a multiplicity other than 1, we need to list it. So if we set each piece to 0, what makes 2x minus 1 equal 0? 1/2. What makes x plus 1 equal 0? -1. What makes x plus 3? Okay, none of those have an exponent on them, so we don't have to worry about multiplicities. Next question. I want to know if our graph is going to go through or bounce at each of these. If it's an even multiplicity, it bounces. All of these have a multiplicity of 1. 1 is odd, so what's going to happen at each of them? All go through. So you can write all through, you can list it Each one, I don't care how you do it, as long as I can understand. Yeah, or you can just say all go through. I usually just list this in the same order as my zeros. Okay. Next thing, I want to find a y-intercept. To get your y-intercept, all you have to do is put in 0 for all of your x's. So 2 times 0 minus 1 would give me -1. 0 plus 1 is 1. 0 plus 3 is 3. Multiply that, and we get -3. Now we can graph. Y-intercept is -3, so I'm going to touch my y-axis at -3. The zeros are your x-intercepts, so I'm hitting the x-axis at -3, -1, and +1/2.
Can I ask a question?
Mm-hmm.
On D, if they are not all the same, do you have to list them in order?
Or you could say it bounces at -1 and goes through at the others. Okay. Now our end behavior, we said our graph is going to start down and ends up. So it starts down here and ends up here. So I'm going to draw, remember a polynomial is a nice curve. So it's starting down here, we go through this 0, come back and hit this one, we go through, got to hit our y-intercept, come back and hit this, and then goes up. Is this a perfect graph? No, I don't really know how high up this goes, but all my x-intercepts are in the right spot, my y-intercepts in the right spot, and my ends are going the correct direction. That's what I'm going to be looking for on these. You can always, it's a great idea to graph that original on your calculator and double check that this graph matches up and you don't have any mistakes. Are there any questions there?
So when you graph on the calculator, you graph the one that 2x minus 1 times x plus 1.
That one okay? Let's do this one first. So first question, degree. If I multiply this out, we have an x squared times an x cubed. So what's my degree? X to the 5th, degree 5. And behavior. So it's a positive x to the 5th, so I don't have to worry about flipping or anything. Down, up, because it's odd degrees, so your ends are going opposite directions. Okay. What's the next step? Zeros. What makes x minus 1 equal 0? Positive 1. What do I need to put with that? Multiplicity 2 because of the square. Okay, what makes x plus 2 0? -2. What goes with that? Multiplicity 3. Okay. 1 has a multiplicity of 2. 2 is even, so what happens there? Bounce. -2 has a multiplicity of 3. 3 is odd, so the graph will go through. Y-intercept. I put in a 0 for my x's. 0 minus 1 is negative 1 squared. 0 plus 2 is 2 cubed. Negative 1 squared is 1, 2 to the third is 8. So I get 8. So now we can graph. Gonna touch my y-axis at 8. I'm just gonna count by 2's there. My x-axis at negative 2, positive 1. My end behavior is down up, so we're going to be starting down here. It should end up here. Okay, so start at negative 2. Does my graph bounce or go through? Go through. So go through, hit your y-intercept. What happens at 1? So we're going to come back up, and that's good because that's the direction I said we would end. Do we have questions on that?
So like, how is the 2 a 0 3 times? Did we only hit it?
We only hit it once on the graph, but essentially, okay, you could think through, you hit it going up, you came back down, you hit it a second time, going back up, you hit it a third time. That's why anytime the multiplicity is odd, it ends up going right through it. This one has a multiplicity of 2, so you hit it once on the way down and once on the way back up. That's why evens bounce. Other questions? Overall, how are we feeling about this? Not too bad. Let's do this one. How is this problem different? Not factored. Okay. And we have a negative out front. So A. What's our degree? 3. If it's not factored, you just look for the highest exponent. So B, your end behavior, since it's a negative, that flips your end behavior, so it's going to be up, down. Okay, C. Since it's not in factored form, we're going to have to do a little more to find our zeros. Looking at this, what could you do? Okay, I pulled out negative x. Then what could you do? Box method, just like we've been doing on all of our other problems. So these multiply to negative 2, and they need to add to positive 1. What would that be? 2, negative 1. So we get 2x minus 1, x plus 1. So we found our factored form. Okay, so what would make x 0? 0. What makes 2x minus 1 0? And x plus 1. Negative 1. So once we get it factored, we can find our zeros. Any questions so far? All of those have a multiplicity of 1, so what's the graph going to do at all of them? Through all of them. Or you could write it 3 times. Y-intercept, if you put in 0 for all of your x's, get 0 out, right? So now we can graph. Y-intercept is 0. X-intercept's at -1, 0, 1/2. Said my graph should end up, or start up top and end down at the bottom. The only places I can touch my axes are the dots that I marked. We said we're going to go through all of them, so we're going to come down, go through this, hit my 0, go through, hit this one, go through, and we got it. Alright, I've got more examples. Do we need more? Do you know what's going on?
I think we're good.
Think you're good? Okay. Then you've got about 20 minutes or more actually right now to work. There's a handout posted on Classroom, and